Hello, we are in Chapter 5, Section 5.6, Rationalizing Denominators. In this example, we're going to go over problem number 1, in which we are to rationalize the denominator of several fractional radical expressions. In part A, we have just a single radical factor in the denominator, so we multiply by another instant of it in both the numerator and denominator, and that results in just the radicand in the denominator, which in this case is 11, and in the numerator 5 times the square root of 11 is simply 5 square root of 11. No further simplifications are possible, so we're done with this one. In B, we have a similar situation, so we again multiply by that radical that we have in the denominator into both the numerator and denominator, and then we get the radicand, that is 5, in the denominator, and in the numerator, the square root of 6 times the square root of 5 can be rewritten as the square root of 6 times 5, which is 30. Now, the 5s can be simplified in here, and at the end we get just the square root of 30 as our final simplified answer, since 30 doesn't have any perfect square factors. In part C, the situation is a little bit different, because instead of a square root in that denominator, we have a cube root. And it's the cube root of 2 that is not a perfect square. So to get the radicand by itself, we need to cube the cube root of 2. Therefore, we need to multiply the cube root of 2 by itself 3 times. We only have one of those cube roots of 2 in that denominator, so we need to multiply 2 more. And 2 more of the same thing is the square of that thing. So we're multiplying the cube root of 2 squared into both the numerator and denominator. And let's see what that results in. In the denominator, since we're getting 3 of those cube roots of 2 multiplied together, that gives us just the radicand 2, and in the numerator we get 8, and then the cube root of 2 squared is the same as the cube root of 2 squared. Now we acknowledge that 8 and 2 have a common factor of 2, so we divide them out, and we end up with 4 times the cube root of 4. And since the 4 as the radicand of that cube root doesn't have any perfect cube factors, we are done with this. Now in part D, we have another cube root of a fraction, so we first rewrite it as the fraction of cube roots. Now we acknowledge that the cube root of 8 is simply 2, and 45 has perfect square factor of 9, so we want to perceive that 45 as 3 squared and 5. So using the product property of radicals, the cube root of 45 can be rewritten as the cube root of 3 squared and multiplied by the cube root of 5. So to rationalize this denominator, we have 2 of those factors. One of them is the cube root of 3 that is already squared, so it's enough to multiply in one more cube root of 3 to have altogether the product of 3 of them, to release that 3 as the radicand. And we have only one instant of the cube root of 5, so to get the cube of that, we need to multiply in 2 more, so the cube root of 5 squared. And of course the same thing into the numerator. Now in that numerator, we actually want to write it as the cube root of 5 squared, because it will be easier to simplify in the next step. And now starting with the denominator, we get that 3 from the first product, since this is the cube root of 3 to the third altogether, and then 5 from the second product, because we have 3 of those cube roots of 5 multiplied together. Now on top we still have the 2, and then the cube root of 3 can be multiplied by the cube root of 5 squared, which is 25, to get the cube root of 75. Now 75 doesn't have any perfect cube factors, and there is no other possibilities to simplify between the numerator and denominator, so we just rewrite the final answer in that form.